Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is vinyl cyclopropane, a cyclopropane ring bearing a vinyl group, i.e., an allyl-type system. When HBr adds to the double bond, protonation occurs at the terminal carbon, Markovnikov's rule, to generate the more stable carbocation. Moving on to the next step. HBr protonates the alkene. According to Markovnikov's rule, the proton adds to give the more substituted, more stable carbocation. In vinyl cyclopropane, protonation at the terminal vinyl carbon gives a carbocation adjacent to the cyclopropane ring, a cyclopropylmethyl or homoallyl type cation. Moving on to the next step. A cyclopropylcarbonyl cation is exceptionally stable, more stable than tertiary carbocations due to ring overlap, and readily rearranges. The options A, B, and C each propose a specific rearrangement pathway and product. Option A shows ring expansion to a cyclobutyl cation. Option B shows ring expansion to a cyclopentyl cation with one regiochemistry. Option C shows ring expansion to a cyclopentyl cation with another regiochemistry. And for the final step. Option A cyclobutyl cation, secondary, 4-membered ring, is less stable than a cyclopentyl cation and the rearrangement shown, cyclopropane-cyclobutane, via 1,2 shift is not the most favorable pathway here. Option B proposes a ring expansion from cyclopropane to cyclopentane via a homoallyl cyclopropylcarbonyl rearrangement, which is well known, but the regiochemistry and mechanism shown may not be exactly correct. Option C also proposes ring expansion, but with a slightly different arrow pushing or regiochemistry. Option D, none, the question's correct answer. None of the proposed mechanisms, A, B, or C, correctly and completely describes the actual most likely reaction pathway with the correct regiochemistry, correct carbocation intermediates, and correct product. The actual mechanism involves a cyclopropylcarbonyl cation that can ring open to a homoallyl cation or expand, but none of options A, B, or C accurately depicts the correct sequence of events and the correct final product regiochemistry. Therefore, none of the given mechanistic pathways is entirely correct. Therefore, the correct answer is D. Therefore, the correct answer is option D.